We gaze at Mars, a red beacon in the night sky, a distant world that has captured our imaginations for centuries. It beckons us, a symbol of humanity's drive to explore, to push beyond the boundaries of our home planet and venture into the unknown. We dream of walking on its surface, of building a new home among the stars, a place where future generations might thrive and expand our presence in the cosmos. But the journey to Mars is fraught with challenges, both technical and environmental, that test the limits of our ingenuity and resilience. The red planet holds its secrets close, guarded by a harsh and unforgiving environment, with dust storms that can last for months and temperatures that plummet to extreme lows. One of the biggest hurdles is the lack of a protective magnetic field, which leaves the planet vulnerable to the relentless assault of solar radiation. Earth's magnetic field acts as a shield, deflecting harmful solar radiation and creating a safe haven for life to flourish. Mars, however, lost its global magnetic field long ago, leaving its surface exposed and barren, a stark contrast to the vibrant life on Earth. This leaves the Martian surface exposed to the sun's wrath, with high levels of radiation that pose a significant threat to any potential human settlers. Without this protection, any hope of a thriving Martian colony seems like a distant dream, a vision that may never come to pass unless we find innovative solutions. But what if we could give Mars a helping hand? What if we could harness our technological prowess to create a new magnetic field or develop advanced shielding techniques? What if we could engineer a solution inspired by the cosmos itself, using the very forces that shape our universe to protect and nurture a new world for humanity? Mars already has two small moons, Phobos and Deimos. These moons, though tiny compared to Earth's moon, play a significant role in the Martian sky. They are like celestial dancers, forever circling the red planet in a cosmic ballet that has been ongoing for eons. But their small size limits their influence. Unlike larger moons, they cannot significantly affect Mars' gravitational field or its potential for future colonization. What if we could harness their potential and create something new? What if we could merge these two moons into a single, larger entity? Imagine merging Phobos and Deimos, combining their mass and momentum. This would not only increase their gravitational influence, but also create a more stable orbit. This ambitious feat of celestial engineering could give birth to a new, larger moon for Mars, a moon that could potentially stabilize the planet's axial tilt and climate.
The process would be complex, requiring precision and immense energy. Engineers would need to develop new technologies and strategies to achieve this. We would need to carefully nudge Phobos, accelerating it in its orbit. This delicate maneuver would require advanced propulsion systems and precise calculations. This would send it on a collision course with Deimos. The timing and angle of impact would need to be meticulously planned to ensure a successful merger. The impact, carefully orchestrated, would fuse the two moons together. This collision would release a tremendous amount of energy, reshaping both moons into a single, larger body. This newly formed moon, larger and more massive, would become a powerful force in the Martian system. Its increased gravitational pull could have profound effects on Mars. It would be the first step towards a fundamental transformation. A new era for Mars, with a larger moon that could pave the way for future exploration and possibly even colonization.
A crucial element in this plan is creating a molten iron core within the new moon. This molten core is the key to generating a magnetic field. To achieve this, we would employ powerful, focused energy beams.
These beams, perhaps generated by massive solar arrays, would be aimed at the heart of the new moon. The concentrated energy would heat the core, melting the iron within. This molten iron, constantly churning and rotating, would create a dynamo effect. This effect is the driving force behind planetary magnetic fields.
While a molten core is essential, we can further enhance the magnetic field. The answer lies in the vast expanse of the asteroid belt. Here, countless iron-rich asteroids drift between Mars and Jupiter. We can capture these asteroids, guiding them towards the new moon.
As they descend towards the lunar surface, they would be vaporized by the heat of atmospheric entry. This would create a rain of molten iron, further enriching the moon's core. This added iron would strengthen the dynamo effect, amplifying the magnetic field. It would be a cosmic transfusion, boosting the moon's ability to protect its future planetary companion.
Section 5, a planetary shield deflecting solar winds.
With a molten, iron-rich core, the new moon would generate a substantial magnetic field. This field would extend outwards, enveloping Mars in a protective embrace. Like a shield, it would deflect the harmful solar wind.
The solar wind is a constant stream of charged particles emanating from the Sun. These particles can strip away a planet's atmosphere over time. This is thought to be a contributing factor to Mars's thin atmosphere today. But with the magnetic field in place, the solar wind would be deflected. This would allow Mars to begin the long process of atmospheric regeneration. It would be a crucial step towards making the planet more hospitable. Section 6. Finding balance, stabilizing the Martian tilt.
Mars' axial tilt is another challenge for creating a stable environment. Unlike Earth's relatively stable tilt, Mars wobbles on its axis. This leads to drastic climate shifts over time, making it difficult for life to gain a foothold. The increased mass of the new moon would act as a gravitational anchor. It would help stabilize Mars's axial tilt, preventing extreme wobbles. This newfound stability would lead to a more predictable and less volatile climate. With fewer drastic swings in temperature and weather patterns, life would have a better chance to adapt and thrive. It would be a crucial step towards transforming Mars into a more Earth-like world.
Section 7, a breath of life creating a breathable atmosphere.
A magnetic field is crucial, but it's only the first step. Without it, the solar wind would strip away any atmosphere we try to create. To truly make Mars habitable, we need to address its thin, carbon dioxide-rich atmosphere. This thin atmosphere means that the planet cannot retain heat, making it extremely cold. A thicker atmosphere would provide several benefits. It would not only help in retaining heat, but also in creating a more Earth-like environment. It would trap heat, warming the planet and allowing for liquid water to exist. Liquid water is essential for life as we know it, and would be a critical resource for any future human settlers. It would also offer protection from harmful radiation. Mars lacks a thick atmosphere to shield it from cosmic and solar radiation, which is harmful to both humans and potential microbial life. There are several proposed methods for thickening the Martian atmosphere. Scientists are exploring various innovative techniques to achieve this. One involves releasing trapped carbon dioxide from the polar ice caps and Martian soil. This could be done by using mirrors to focus sunlight on the ice caps, causing them to sublimate. Another involves redirecting ammonia-rich comets to collide with Mars, releasing nitrogen and other gases. These gases would contribute to thickening the atmosphere and adding essential elements for life. These processes, combined with the protective effects of the magnetic field, could eventually lead to a breathable atmosphere on Mars. This would be a monumental achievement in human history. This would be a game changer, paving the way for human settlements and even the possibility of terraforming the planet. Imagine a future where humans can walk on Mars without spacesuits, breathing in a new Martian atmosphere.
Section 8, the power of light solar arrays in deep space. Such ambitious engineering feats would require colossal amounts of energy. Harnessing the power of the sun is the key.
We would need to construct vast arrays of solar panels in space. These arrays would be strategically positioned to capture the sun's energy with maximum efficiency. The energy collected would be beamed to the construction sites, powering the lasers and machinery used to manipulate Phobos, Deimos, and the iron asteroids. This reliance on solar energy would make the project sustainable and minimize its environmental impact.
Section 9, mining the cosmos, capturing iron asteroids. Capturing and redirecting iron asteroids would be another monumental task.
It would require advanced spacecraft equipped with powerful engines and precise navigation systems. These spacecraft would be dispatched to the asteroid belt, where they would identify and capture suitable asteroids. Once captured, the asteroids would be carefully nudged from their orbits and guided towards the new moon. This delicate process would require precise calculations and constant monitoring to ensure a safe and controlled descent.
Section 10, A Giant Leap, the future of Martian terraforming. The idea of merging moons and harnessing asteroids might seem like science fiction, but it is within the realm of possibility.
It highlights the incredible potential of human ingenuity and our growing ability to manipulate the cosmos. Terraforming Mars is a long-term goal, a multi-generational project that would require international collaboration and sustained investment. But the rewards would be immeasurable. It would give humanity a second home, a backup plan for our species, and a chance to reshape a planet in our image.
Section 11, The Cosmic Perspective, a universe of possibilities. As we gaze at the stars, we are reminded of the vastness of the universe and our place within it. The challenges of terraforming Mars may seem daunting, but they also represent an incredible opportunity. By pushing the boundaries of science and engineering, we can overcome these challenges and unlock new possibilities. The journey to Mars is a journey of discovery, not just of a planet, but of ourselves and our place in the cosmos.